the MicroCap 10 program, look at diode decimal to binary decoder tutorial 1 for instructions. 5 flip-flops are wired to shift logic 1s, then logic 0s in a pattern that allows 10 AND gates to decode the 10 output logic patterns of the flip-flops. The node 17 gate is high on count 1, node 21 is high on count 5, node 22 is high on count 6, and node 26 is high on 0 and count 10. Print a copy of this circuit to refer to when you build it. Be sure to check the node numbers of your circuit, as they may be different. Now let us select the transient analysis option. Notice the box values. We have a 10 microsecond range. We have D5, which is the clock input, and count 1 in the first graph, count 2 in the second graph, that's node 18. A D precedes it because it's digital data. Count 3 is in the third graph. Count 8, 9, and 0 follow. The range and the X range and the Y range are both set at auto because this is a digital circuit, and that works very well. Now we'll run the transient analysis. We see here the clock on the rising edge. We get a 1 decoded. The second pulse we get a 2. The third we get a 3. As we approach the end, we get a 8. We get a 9 and a 0, a 10 here and a 0 there. So we see everything is working the way we expect. So we'll exit here. We're back to the circuit. This is the one that we're going to have to build. We take and look at the 1 of this flip-flop and the 0 of that. That decodes the 1. Similar here, 1, 0, that decodes 2. 1, 0 decodes 3. 1, 0 decodes 4. 1 and 0, 1 and 1 decodes 5. Over here we have 0 and 1 decodes 6. 0 and 1 decodes 7. 0 and 1 decodes 8. 0 and 1 decodes 9. And 0 and 0 decodes 10. So you see what we're going to construct. Do is put in our grid. View down to grid bold 5. We have our grid in. Now we'll go and look for a D flip-flop. That's a 74, 74. There we have it. So we come over, we start putting them in. There's the first one, I click it. Second, I click it. Third, I click it. 08, that's an AND circuit. So I click that. I bring the AND circuit down, and I start putting it in there. There, that's decoding 1, that's going to decode 2, that's going to decode 3, that's going to decode 4. I bring this over here, and that's going to decode 5. I bring this back over here, and I'll bring this down some, keep some space here. We'll come over here, and this is going to, that'll be 9. Over here, and that will be 10. Okay, now we have to start doing some wiring. So I'll go up and get the wiring symbol. One of the first things we want to do is hook up all of the set and resets. So I'll bring this along here, and I'll just stop that there. We'll do the same with this, bring it along, stop it right there. Bring this way. it down, put it in place. I'll go back and get the wiring icon, bring this over and attach it to that. I'll bring its input down here. I'll go get a ground and attach it there. So now I have all of these biased high, which means that neither high or low output will get latched up. Now I'll begin the decode. Now I'll wire the units up in the proper shift register fashion. I go back to the wiring icon and I take and tie the first and second together, second and third flip-flop, third and fourth flip-flop, fourth and fifth flip-flop. Now I have to take this last one and I have to take its negative output and feed it back. So I bring it up there, back this way, and move this back over here, and it's going to go to this D input. So what happens is ones get shifted all the way across and then zeros get shifted all the way across and then it repeats again. Okay, the next thing I have to do is I have to tie all of the clocks together. And so I'll bring this clock signal up, leave it there, I'll take it out here, now I'll come down and move this out here, and I'll bring this clock signal back here and up here. Down to stimulus generators, I'll go to the D clock. I have the D clock. I'll bring it over here and put it in place. I don't want it this short. I'm going to change the 50 nanoseconds to 500 nanoseconds. And I'm going to change the other width to 500 nanoseconds. Oops, the other one was not, I didn't put the nanosecond signal in, so I'll click there and there. Now, that's 500 and that's 500 nanoseconds, so I will OK that, and I'll escape from that. Now, we have the clock signal here. We're going to tie it in and it's going to pulse all of these units. Now notice again, all of these are tied to shift ones in until the end. Then this goes high, this goes low, and a zero begins to be shifted in. So you go to the wiring, pick up that symbol, pick up the clock and tie the clock to all of the clock lines. Now we begin the decoding. Now, the 1 is going to be the high output of the first flip-flop and the low output of the second flip-flop. So we bring that over and down. Same here. This goes to the high of the second one and to the low of the third one. Release, click, and release. And the high of the second flip-flop. And this is the high of the second flip-flop. And there, we have that. Now, again, this guy looked at the low of the second flip-flop, and it looks at the high of the third flip-flop. And there we have it. We have it wired up. So, let's see what the node numbers are. All right, and the node numbers that we're really interested in is the clock input, and that's 1. We want to look at the decoding of 1, 2, 3. That's node 13, 14, and 15. And the last 8, 9, and 0. And those nodes are 20, 21, and 22. So we are going to go to transient analysis. Now, because we changed the clock frequency, we're going to want this to be 10 microfarads. On the first graph, we are going to want to have two signals, but they're going to be digital signals. So it'll be D, and the first one will be the clock, that's node 1. And the other one is going to be the decoded number 1, and that was node 13. And we're going to leave auto in all of these. So the second graph, we're going to want to look at the decode of number 2, and that was going to be 14. We have to add some more, so I'll click the add button. That's graph 2. This is going to be graph 3, 4, 5, and 6. And this is going to be, we want 13, 14, 15, and then we want, let's get out of transient, exit analysis, and let's get out of that wiring symbol. Let's take a look at our diagram. Okay, we have this hooked up to a 1 and a 0, a 1 and a 0, a 1 and a 0, a 1 and a 0. So those should be correct. This guy should be hooked up to 1 and 1. So let's follow this line back, and that does go to 1 and 1. Now this guy should be hooked up to 0 and 1. Looks like it is. 0 and 1. Run again. There we are. Okay. So now here we see, this is the clock, and the rising edge of the clock, we get number 1. The next clock is 2, the next clock is 3. Then we come over here to the end, the next clock is, the rising edge gives us a 8 and a 9, and this is a 10, or when we were starting out from 0, that's a 0. So this time we had to use the operating point. So we'll exit transient. And this is the circuit. It's a little large. You can see it all if you come over and demagnify a little bit. Now everything fits in, but it's a little hard to wire it on this small scale. But it gives you an idea of where to find digital components, how to wire them, and how to check them out. That's it for this 10th tutorial.